In a piece of machinery, you are often mounting something onto a rotating shaft. You might have a sheave for a belt drive, or a gear, which we're talking about now, or a sprocket for a roller chain. And how do you keep that thing from slipping as the shaft turns around so that you can transmit the power, transmit the torque from the shaft to the thing that you are rotating? There are various methods of doing that, and I just want to differentiate between an axle and a shaft. Not that we have to argue with anyone about it, but technically speaking, an axle is the thing that does not rotate. It's got a rotating thing at the end of it, like a wheel. A shaft does rotate, and it transmits power. Then the hub is the part of the machine element that contacts the shaft. Usually it's sticking out like this, and it's what makes contact. It can be held on with various kinds of devices. You could, for example, use pins, and this is a page, 2 pages out of Machinery's Handbook. In some kinds of machinery, you might intentionally design a pin to be the weakest part of the machine. And you might do that if, well, especially if you have a machine that's expensive, and if something goes wrong, you don't want those expensive gears to break. You just want your little dowel pin in there to break and leave the gear as it was. So you often find something called a shear pin, which is just a pin that's weak, attaching a thing to a shaft. Retaining rings don't transmit power, but what they do is they keep the shaft from moving axially along the center line. One of the simplest methods of attaching a thing to a shaft is an interference fit, which we discussed if you've taken mechanical design class fall term or some fall term. You have talked about interference fit, or if you take it next year, you will talk about interference fit. And an interference fit is where the hole that the thing goes into is always smaller than the shaft that goes into it. And so that kind of fit can transmit force and stress around that hole. And we looked at, or will look at, these tables where you look up the tolerances for a force fit. Here are the categories. Another way of transmitting torque from a shaft to a thing is with a spline. And a spline, here are a couple of examples. Splines are like a number of keys arranged around the shaft, or like a number of flattened out gear teeth around the shaft. They are stronger than a key because you have several of them and you get uniform loading. You might remember when we talked about spur gears, we talked about the hunting ratio, the idea that in a gear train, it's a good idea to have an odd number of teeth in one of the gears. Well, in splines, that's not a good idea. That's a bad idea because there's no advantage to it, and it just makes it real hard to inspect. Picture putting a caliper around an odd number of spline teeth. They come in 2 different types of forms. One is the involute, and that's the same shape that we saw on our spur gears, that curved kind of shape. And a company like Lin Gear with a hobbing machine could easily cut splines. In fact, I think they do make them for customers. The other version is an SAE spline. Remember what SAE stands for? Society of Automotive Engineers. And so they make standards for automotive parts, truck parts, agricultural parts, off-road equipment parts, and so on and so forth. So they have standards for splines, and the SAE spline is straight-sided. If you've ever worked with a tractor with a power takeoff, for example, you've probably seen these splines. If for some reason you need to draw splines on your drawing, luckily you can do the same sort of thing you do with spur gears, which is draw a simplified drawing. This one shows I don't know what this is, the shaft with one spline key shown, but most of it is represented with a phantom line. Now, let's go on and talk